Okay, are we live? Are we here? Hello. What's up, stream? Welcome back. Hello, hello. So, today we're going to go over some more of the problems from LeetCode. And praise God, it's the Lord's Day. And so, thank you, God, for another day, another week. And here we are. Let's go ahead and I guess we'll get right into it here. I don't have too much to say, I suppose. Just want to keep practicing. Okay, so design tic-tac-toe. So this should be interesting. We'll see how this goes. What are they asking for here? So assume the following rules are for the tic-tac-toe game on an n-by-n board between two players. A move is guaranteed to be valid and is placed on an empty block. Once a winning condition is reached, no more moves are allowed. A player who succeeds in placing n of their marks in a horizontal, vertical, or a diagonal row wins the game. Implement the tic-tac-toe class. Tic-tac-toe in div n initializes the object the size of the board n. Initializes the object the size of the board n. Row and column in player indicates that player with ID player plays at the cell, row, column of the board. The move is guaranteed to be a valid move. Follow-up, could you do better than quadratic time per move operation? Interesting. Okay, so oops. Input moves output. Excuse me. Turn 0, no one wins. No one wins, no one wins. Player 1 wins. Most unsquared calls will be made to move. Excuse me. Well, I don't know what's going on, why I'm yawning so much. So, assume the following rules are for the game on this board between the two players. Move is guaranteed to be valid and is placed on an empty block. Once a winning condition is reached, no more moves are allowed. Player succeeds in placing n of their marks in a horizontal, vertical, or diagonal row wins the game. Implement the class. Initializes the object the size of the board. Move indicates the player with an ID plays at the cell of the board. The move is guaranteed to be a valid move. Could you do better than quadratic time per move operation? Excuse me, so I think okay. So we're returning one of three conditions. Player 1 wins, player 2 wins, or nobody wins. Okay. So that's what we're intended to do. We're gonna maintain the state of the board as well. Alright. So the diagonal and the board can be of any size. So we're going to try to do better than quadratic or quadratic time solution, quadratic time algorithm. What we could do is, so I think the simplest thing is to have a vector of vectors or an array of arrays. Excuse me. I think vector of vectors is fine. And that'll give us the board state, right? So rows and columns. And we just update the board state as we go. Now the tricky thing here is updating the board is constant, right? Putting a character in a certain spot. However, when you want to check whether or not you've won, you could do it in linear time to check if you won. You could do a linear per move operation, right? Because depending on the row column, you just check if that whole row or that whole column is the same, I suppose. And yeah. Excuse me. And you could do slightly better than that too, is you could have like a count for, you could do something like this where each row and each, you have a data structure for each row and each column will keep a count of the number of, I think we use X's and O's for Tic-Tac-Toe. Keep a count of the number of X's and O's that have been placed in that particular row or column. And you have a pair of integers that represents that. Number of player 1 values in there, and number of player 2 values in there. And then, so when you do your check, when you update the row column, you say, yeah, actually that's even better. That's even easier. You actually, at that point, you don't even need any kind of validation for, you don't even really need a, like, they're saying that we're going to guarantee every move to be a valid move, right? So you don't even do validation. So you don't even really need to maintain the board state. You can literally just maintain the rows and columns values, row and column values. And then you also have a diagonal and anti-diagonal values to maintain as well. That's it. So we'll do it this way. We'll try it this way. So we'll say standard vector of pairs. Row count, column count. And these are both going to be n and 0, n and 0 for each column and each row. And yeah, n rows and columns, yeah, it should be fine. And then we have anti-diagonal and then diagonal. And we say row count of player equals 1. And then player equals 2. Row count of row plus plus dot first plus plus column count column first plus plus, and if row equals column, anti-diagonal first plus plus, else if row, so being on the diagonal is the same. Actually, that's actually the anti-diagonal, is that they're the same. The diagonal would be basically row is equal to n minus column, something like that. So you have, so all the way at the bottom you'd have, so n minus the, I'm sorry, actually these are reversed. This is the diagonal. It's confusing. No, that is the anti-diagonal. Yeah, the anti-diagonal goes this way. No, wait. I don't know which diagonal, which is anti-diagonal. Diagonal, which one's which? Anti-diagonal. It doesn't really matter. I think it's arbitrary. We'll say the one where the rows and the columns are the same are the anti-diagonal, and then when they're different, it's got to be the oh yeah, this actually, and I have to be careful to do both because you could actually add both to the anti-diagonal and the diagonal at the same time by if there's a middle element. And that's going to be, so the anti-diagonal is going to be when they're equal, and when they're not equal, but they're, or not necessarily equal, but you've got the row would be n minus 1 and the column is 0, right? So n minus 1 equals n minus column minus 1. And then you have row is n minus 2 and column is 1. Yeah, n minus 1 minus column. A little confusing. That's the diagonal, and that's the anti-diagonal. And then if it's player 2, then you're going to map to the second. Excuse me. Now, I'm not really sure pairs, it gets a little confusing because it's like, it's almost like I want to use a tuple, but I do want to use a pair. I don't know. It's a little confusing. We'll just, I believe you can modify a pair. I don't know if you can modify a tuple. We're just going to leave it as it is. We're going to just do it this way. There's like, I'm just thinking if you have a similar kind of a setup and you have multiple players, you don't really want to, have first, second, third for an arbitrary number of players. Like here, there's only 2 players, so this is kind of easy to write it this way. However, it can be a little awkward to write this in a more generalizable way, I guess, something like that. You could do something with tuples probably. We're gonna, or a vector in here instead of a pair. Make these vectors, something along those lines. Anyway, so yeah, and what we want to return is basically if row count of row, Boolean, we'll just do Boolean check. Row count is going to be one of the following. Row count of row is greater than or equal to n, or column count of column greater than or equal to n, or antidiagonal, and actually it's the first, right? First to first to first, finally diagonal. All right, I'm gonna do the same thing on the other side. Check, let's just do second. Basically, this is like duplicate code. This whole, it's like not great to have duplicate code because of, yeah, it's like not great to have duplicate code because you know what we can do? Could do something like auto row count. Like I want to define a bunch of references, but I want to define the references with respect to the player, and then increment all these things, and then test them. I think we'll take a look at that in a second. Let me just see if I have the right idea here. Compiler error, nice. What did we do wrong? Oh, it's up here. Really? What's wrong here? Unqualified ID. What? Oh. Oh no. Did these wrong. Something like this. Oh, is this not supposed to have 3 of these? Am I crazy? Why do I think I have so many of those? Oh, and these are, right, duh. These are pairs, of course. Oh, yeah, okay. So this is a pointer, yeah? There we go, okay. Oh, it works. Sweet. Is there another example we can get? Could we just go for it? I don't know. I'm tempted to just go for it. I'm so tempted to just go for it. Like, it's so much extra work to set up the test cases for this. That's so tempting. Let's just do a diagonal game. Let's do one of these diagonal, anti-diagonal games. Yeah, it's so tempting to just go for it, but it's such a bad idea. It's wrong. Alright, we're gonna say player 1, player 2, player 1, player 2, player 1, player 2. Let's go with, what's 3? Okay, yeah, let's do 4, or let's do 3, and let's do, yeah, 0, 0 for 1, column 1 for 2, 1, 1 for 1, and let's do column 2 for 2, and then at the end we do 2, 2 for 1, and I think that should be it. Right? 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Let's see what we do here. 4 milliseconds. Okay. And if we do the antidiagonal, so this is the other direction, which is 2 minus 0 minus 1. Is that right? It's the row is n, which is 3 minus 0 minus 1. It's really, yeah, it's n minus 1 minus the column, right? So 2 0, and then 1 1, and then the last one is 0 2, which is what we need for this guy. So we'll have to do 0 1, and then how about 2 1? What does that look like? All right, that's like the antidiagonal. Do we just go for it? I think we just go for it. I don't know. I'm so tempted. Let's just go for it. Hey, it worked. Hey, sweet. Nice. All right. Yeah, cool. Not bad. I feel like a smart guy now. I got the. Actually, this is way better than quadratic time. This is constant time. The whole thing. Let me see if I can kind of clean this up. And how did we do? We had 20 minutes. Yeah, not too bad. Let me see if I can clean this up a bit. This we've got going on here. I want to say. I'm going to say auto row pair is equal to excuse me, row pair, row count of row, row column pair, column count of column, we could do something like this. We could kind of make this all in one. Right, there's the column pair, the row pair, diagonal. Actually, those pairs are the same, no matter what. And we want to say, we don't really need to do that, do we? We could just say, we could do something like auto reference row is row count of row. Let's say player equals 1. If that's true, then we'll do the first. Otherwise, row count row of the second. Just so we didn't really change anything, did we? Doing this. Or just P row, something, or just board row, B row. I'm not really sure what I want to. Okay. So we can do B row, or row, or P row, or row P. I don't know. And we can say column P, and there's diagonal P, and antidiag P. And we would say this is column count of column. And then this is just diagonal. And then this is antidiagonal. This is a little bit cleaner, I think, because now we can retire this piece of code and then write all of this in one shot and say row P plus plus, excuse me, column P plus plus. If row is column, we have antidiag P plus plus. Don't need to have the first in there. And then this is just diag P plus plus. And we do a check. If any of these are row P is greater than or equal to n, or column P is greater than or equal to n, or antidiag P is greater than or equal to n, or diagonal P is greater than or equal to n. Right? Now if check, return the player, otherwise return 0. Something like this. Let's see if this still works. Is this still correct? Yeah. Alright, pretty good. I think this is a little bit slower though. Possibly. Nope. Pretty good. I mean, we're fast. We're super speedy. 99%. I like that. I like that. That's good. So yeah. There you go. Not too shabby. Almost 30 minutes in. Yeah, this is great. I thought this was going to be so much more involved, this tic-tac-toe question. I'm grateful this was not too challenging, not too difficult. I don't know, part of me was like half expecting to spend the next 3 hours looking at this. Yeah. So we want, what else do we want to do here? I mean, that's fine, you know, that's fine. There could be, you could even clean this up a little bit too. I think you could even do this if you wanted to. Wrong. Oh. Whoa. What happened there? Wait a second, what? Huh? Uh-oh. Huh. Really? Oh, that's interesting. Oh, I know why. Ah. These still need to be references. Yeah, that's why. That's a tricky little thing that can happen. Yeah, it's important. You don't need to make these all these different lines. It seems to be a lot slower. Oh, no. It's okay. Anyway, so yeah, I mean the idea is really simple. You basically just keep a count of how many things have been placed for that particular player, for that particular row, column, diagonal, or antidiagonal. And if you have all 4 for a particular player, once you've placed it, right, obviously you know which player that you're placing it for, so you can do the check right after you place it. And if you make it, then you're done. If you don't make it, then you keep going. And that's it. Yeah, it's pretty simple. I mean, this is great. This is good. Yeah. Can do this in constant time. Oh, not bad. Not bad. All right, let me go ahead and end this one here. So thank you for watching. Hope that was interesting, entertaining, enjoyable, what have you. And I will talk to you soon. Have a good rest of your day.